Okay, hello. So section 2 of the lecture for this module for water and watersheds. I want to just go over what do you need to either learn or make sure you understand this week. And so the first module was intended or the first part of the lecture, sorry, getting my words confused here. The first part of the lecture was about the interconnection of human and natural systems. So water is a really clear example of how human and natural systems intertwine. So that's an important thing to understand. So we've got the systems theory start, and we know that these systems are interconnected. And so now in this one, I want to talk about what a sustainable system would have as what would be the criteria of a sustainable water system, equity, environment, and economy, and what are the main sustainability issues with water. And we have kind of alluded to some of these already in our conversations around climate change, but let's just go ahead and break it down for water. So, water is fun. Water is part of life. It's necessary for life, and certainly necessary for human life. So, any system that respects life respects water. So, in terms of the equity, social equity considerations and sustainability, what would you need to know you had a sustainable system? You would need equitable access to water. I don't say equal, I say equitable access to water for drinking, for present and future generations, bottom line. Equitable access to water for other human uses like agriculture, and equitable safety from water risks such as flooding. So why do I include that in the equity section instead of the environmental section? Because flooding often, the way that it impacts equity seeking groups, or whether we're looking at by income or by racial status, flooding often has impacts that are higher for low-income groups or equity-seeking groups, depending on the context you're in, whether that's by race or culture. So in terms of the environment, what are the environmental criteria for a water system? Water runs through a human system without damage. That would be a sustainable system. So I've damaged my water by making it into coffee. I'm running it through a human biological system, and it's going to come out not quite clean enough. And so I need to make sure that that water is transformed back into clean water before it re-enters in the environmental systems. And the other sustainability condition is that water in the terrestrial and aquatic ecological systems is sufficient and clean. And I'm saying sufficient instead of saying the same as it ever was, because we're in a dynamic environment. Sufficient for biodiversity, sufficient to ensure that we have the primary ecological productivity that we need from wetland and aquatic ecosystems. Sustainable economy, so that there's sufficient water supply for the human economy, for which humans can provision themselves, the way we provide ourselves with food and other material goods, and many processes require water. And So that can include, you know, hydroelectric systems or other kinds of systems. And but the way that we handle water economically needs to be efficient, meaning a lower cost per unit than other alternatives available. So sometimes we think about, I'll just give you a quick example of efficient water handling from a community perspective. So that example that I just gave you of the coffee drinking, at a community level, in some communities, everyone could have their own septic systems, or possibly we could build a special little house where our wastewater went into a pond with tilapia and plankton, and we cleaned the water and had fish to eat by using the products of that ecosystem and running those, you know, that water could also feed the plants inside our house. Sometimes people have an image of a sustainable household where all of the infrastructure system is in the house, which is actually quite expensive. It's expensive to do everything, all those systems inside a single dwelling that's only going to support a household. So it's also expensive to do good individual septic systems. It's expensive in land. It's expensive in sort of the per unit investment. So it's more efficient, given those alternatives, to have community water treatment where the households can share the water costs, which is not to rule out systems where, you know, right now the common infrastructure system for water is to put a lot of our household waste into the water, run it through the sewer to a treatment plant, and treat it there. There's some inefficiencies in that system, even though it's sort of how we assume things are going to happen. But, you know, there might be other systems where we could separate, you know, the less polluted, the gray water, from the more polluted water that needs more treatment. So gray water is like after you use the water for washing dishes or doing laundry or something, you can, with very little treatment, maybe just some aquatic plants, you can use that water on your garden, depending on how you manage things in your household. That water might not need very much treatment at all. Now, currently our sewer systems aren't designed to have that water removed. They need that water in them. But when we have a big volume of water going down to the treatment plant, there's some cost efficiencies in that. Maybe it would be cheaper to do more community wetland water treatment. But when we're evaluating systems, try to think about, is it can we share the cost of that across the community, or does everyone need to have their own system? So that's almost like it's almost like economic moral reasoning. If everyone did this, how much would that cost, sort of thing. Anyway, efficiency. Lower efficiency specifically means lower cost per unit compared to the alternatives. So what do we need to be efficient about? How we handle rainfall, how we treat drinking water for drinking, how we handle stormwater, which is, in this context, I'm separating it. Rainfall would be rain that falls on an ecological system, and stormwater is rain that falls on usually a human system and runs off. And how we handle liquid waste, which is the one I was just talking about. So obviously we also need obviously we often need water for industrial purposes in the human economy, but look at that. Is it sufficient? Is it excessive? Is it efficient? And look at those as criteria. We want it to be sufficient and efficient, economically speaking. So probably the most commonly talked about water sustainability challenge on a household level or a community level is overconsumption. And the reason, so this is, it's kind of an economic concept. It's excessive how much we consume. And the reason that's seen as a sustainability challenge, because if you were meeting the condition that everything that went through the system was just as clean as when you first started to use it, how much water you ran through that system might not be a sustainability challenge, because water doesn't disappear. But water, the provision of water for drinking or for other uses, requires both energy and investment in infrastructure to make sure it's of sufficient quality and to make sure it's where it's needed. So it has energy and infrastructure investment for distribution. And there's often a capacity issue in the source of supply. Excuse me, sneezing. So a sustainable condition around consumption would be in that, using those same system criteria, where that energy required to regularly provide the water, run it through the treatment plant, through the pumping station, the energy would all be from renewable resources, and where there was no net loss to ecosystems. If you can imagine a flow going past a human place, and you take some in and you use it with renewable energy, and you return it just as clean and nice to the same ecosystem. And then you'd have the cost of that system be equitably distributed and as low as possible, efficient. So we're not really making those criteria, which I'm sure you're aware of. So I guess I wanted to talk about source of supply before I go into how much water we're using. So there are some water sustainability challenges that's like overconsumption, but it's related to how much we are diverting from a natural system to meet those supply needs. So the diversion of water from an ecosystem context to human use is unsustainable, where either the rate of removal from a groundwater aquifer is greater than the recharge rate. So that's an overconsumption from an aquifer. An aquifer is a renewable resource. We should be able to use it, but we should only use it equivalent to its recharge rate. That would be a sustainable condition. And then there's another, but this is more of an overconsumption issue that I alluded to with source of supply, where we're removing all the water from a surface watershed without leaving enough to support an environmental ecosystem. So this is if you're thinking about water as a flow, how do you take all the water out? You're putting some back. Well, when we're looking at a sort of an arid region, might lose a lot from evaporation and have it go to a different region, for example. So the Colorado River, so the 4 Southwest states and Mexico, Colorado River, originates in Colorado, goes through Arizona, Nevada, and California gets a share of Colorado River water, and then its outflow was once through Mexico. And there was an interstate compact between those states that was made a long time ago, when there was actually more flow in the Colorado River. And so each state has a right to a share of the Colorado River, which adds up to more than the total flow in the river itself. And the Colorado River has regularly been running dry as its old path reaches the ocean in Mexico. So that's had some ecosystem effects. So I don't think we have, I'm trying to think of any examples in Canada that we have where we take all the water out of a surface watershed. And I can't think of one. But in arid regions, and also, I know what, here's a British Columbia example, where someone might want to divert the water from a stream for a distance. So say to do run of the river or near the river hydro development. One of the ways to do that is to take the water in the stream at a certain elevation and divert it into a pipe, so you get a certain amount of power from the force of the water going down the pipe. And some proposals, when that was a thing that people frequently made proposals about, some of those proposals were going to remove all the water from the stream bed, which would clearly have a disruptive effect on that run and all the fish and the bugs and the aquatic systems that are there. So sustainable water use condition, then back to what we were talking about, is where the rate of water removal from an aquifer is equal to or less than the recharge rate, or there's no net loss to the surface watershed from human water use. That's a very strong criteria, that bottom one. Because if you think about how people use water for lawn watering, and lawn watering in particular, not to have a hobby horse about it or anything, but you take water out of often a surface watershed, sometimes an aquifer, and you spread it out on a surface where it evaporates and goes somewhere else. So you're actually removing it from its home ecosystem. And so you're reducing the amount of ecological productivity that you can get out of your home ecosystem by, watering your lawn. A lot of people watering the lawn say. And irrigation is a much larger scale way of doing that same thing. So I wanted to just talk a little bit about, I know a lot of you are interested in working kind of in the Prince George context. So down in the documents that are in the sustainability area on the City of Prince George website, there's a water conservation plan that was done a while ago, addressing source of supply, sufficiency of supply, some of those, and then addressing conservation. So if you look at this estimated average per capita demand, here I keep going back and forth because I can't press on things. 837 liters per hour. Liters per household per day, sorry, liters per household per day. 837 liters per household per day. And in the winter, households are demanding about 600 liters per household per day. So when you do residential development, there's actually regulations that require developers, cities, to ensure that they have available, well, we used to call it gallons. We used to call it 500 gallons a day. Excuse me, which is like 2,000 liters per household per day. But I don't think that we really expect anyone to use 500 gallons per day in their house, but that's still basically the provincial license rate for water users, and it's the requirement for developers. However, it's a very high level of water use, but there is a peak demand in Prince George of 1,250 liters per household per day. So if you divide that by about 4, for those of you who don't understand my ancient use of the gallon, a lot of rules of thumb in construction and development are in gallons and feet and inches, and it's hard to go back and forth. So in peak demand in Prince George is about 1,250 liters per household per day. So I was working on a water infrastructure plan for a small community. I'm just going to tell this little story. And so looking at what, you have that design criteria of what you would be required to demonstrate for development or to build another house, which is a much higher rate than actual use. But the interesting thing when you start to look at water system design are those peak rates. And again, hoses and lawn watering start to make up a huge portion of how you might design your system. And if you think you need to have show this much supply, and you need to have this much reserve in the system. And then the other set of criteria that people run up to when they're designing water systems is the amount, what's called fire flow, the amount which you need a peak demand for quite a massive amount of water to be available in case of fire. So, but those are like the design volumes, but whereas there's reasons for having high peak design volumes, but these are the usage, per capita daily usage comparisons. So where does Prince George fit in cities across the province? Now, I've just borrowed this graph out of the Prince George plan, and so that pointing out that Kelowna has metered water consumption is a little bit pointing out that, might be trying to point out that there's a system where if you have to pay for each unit of water, maybe you won't consume as much. Of course, Kelowna is also a very dry place in terms of water supply, so they are going to also, along with that metering, they also have water use restrictions regularly. So when I look at this graph and I see a place like Williams Lake, a relatively small community with a huge relative to the others, a huge consumption rate of water, I don't actually think that the people in Williams Lake are all filling up their swimming pools and draining them onto the fields. I actually think there's probably another infrastructure problem going on. So this is per capita daily usage, and so you have to think about where this number comes from. It's how much water are they distributing from the plant? And so there's two things that are going to be in this number. And one of them is going to be how much individually people shower and water their lawns, and the other one is going to be how much leakage there is in the system. So the other thing you could think is that the Kelowna water supply, they probably monitor for leakage because they don't have that much supply. So Williams Lake, I would say, probably has some aging infrastructure for water distribution, or it definitely has a leak somewhere. So, and the reason my basis for that, so I'm just really talking about how do you go about conserving water? Do you put meters on the system so that people have to pay for what they consume? then you can only meter what's actually going to their house. Or do you put meters throughout the system? And Prince George was actually starting to do that in this conservation plan. Do you put meters throughout the system so you can start to see where there might be some leakage, or where in the system is all this water going? So Water Smart program, and I put an example of one from the Columbia Basin, because again, familiarity with it. Water system leakage in some communities was accounting for 30 to 40% of the whole system demand. In Prince George, they were estimating a 5% system leakage, and putting meters on in the system to identify and address those potential leakage locations. But there's a system monitoring that's required to find those, identify them, and fix them. But it definitely helps meet some sustainability criteria if the water that you have acquired and then treated is then not actually just leaking out into the ditches. So if you have a look at that Columbia Basin Water Smart report, that was an example where Water Smart coordinator worked with a number of communities and helped them determine what their consumption rates were, and look at whether they were more likely household or more likely leakage. So back to that point about the point I was making in the first lecture about the role of data. If you have a community that has the system impacts the system feedbacks where it would like to lower its water production, then you can provide the data through monitoring and through expert consultation to help them identify how to save some money by fixing leaks. So there you have some data, you have an immediate application for it, and you have decision makers that can compare the cost. Well, what if we didn't fix the leak? How much would that cost over time? So you have some system interventions that you're able to make in water conservation where it has a high likelihood of affecting decisions, because communities pay and then distribute to their taxpayers the whole cost of water production. They don't always pay the whole cost of the capital infrastructure, but because they get grants for that, but they do pay the whole cost of producing it. And that's my first lecture on the second piece. That's really on the supply end of local water.